First question, it's suggested that the sequence 2 to the k plus 1 produces only prime numbers. So first of all, we just have to sub in k equals 1, k equals 2 and k equals 3. A1 is 3, A2 is 5 and A4 is 17 and they're all prime. The next part, we've got proved by counterexample that the sequence does not always produce prime numbers. I'm going to have a guess that A3 is not prime. If we go 2 to the 3 plus 1, that's 9. Easy mark to say 9 is not prime because it's 3 times 3. Second question is the angle that the vector makes with the positive y-axis. I'll do this in terms of two vectors and the angle between them, where my first vector is 4, minus 1, 3, and my second vector is 0, 1, 0. So that's just my positive y-axis. So we just need to calculate the magnitude of each one. Magnitude of A is 26, magnitude of B, much easier, is just 1. And finally the dot product of A and B, so 4 times 0 plus minus 1 times 1 plus 3 times 0, that gives minus 1. And then we can put that into our formula for cos of theta equals minus 1 over root 26, and we got our final value for theta. Question number 3. First of all, we've got to rearrange this equation for x. So there are two x's in this equation. The most important thing to get right at the start is which x you're rearranging it for. So I've got 6 times the cube root of arcsine, so I'm going to rearrange it for this x over 6 all cubed in the sine part. So if I start taking things over to the other side, 1/10 x plus 1 over to the other side, divide all of that by 3, then take sine to the minus 1, which is the same as arcsine, so it doesn't matter which one you write. Then take the cube root to get rid of that cubed, and then multiply everything by 6. For our second part, we've got a value for x0 equals 4, so if we sub x0 in as 4, then we'll find our value for x1. Then if we sub in this value for x1, then we'll get the value for x2, and sub in that value for x2, and we get our final value for x3. So for x1 you should get 4.716, x2 is 4.802, and x3 is 4.812. First up, we have a geometric sequence. So our first term is k plus 2, next term 4k, and third term 2k squared. So if we know the ratios are the same between each of these, if we do 4k divided by k plus 2, that's the same as 2k squared over 4k. And if we rearrange this equation, we can solve this all for k. So I'll get everything on the same side. I can take out a factor of k, divide by 2 as well, and then we get two solutions, either k is 0 or k is 6, but we were told that k is positive, so therefore k must be 6. Question 5, we have a polynomial long division. So first of all, what do we want to times x squared by to get x to the 4? And we want to times it by x squared, so I'll put that first factor up at the top. And I'll times everything by x squared. So I get x to the 4 minus 2x cubed minus 15x squared. Then I'll take away those equations. So I get 4x cubed minus 14x squared, and I'll take the next term down. Now to make 4x cubed, I need to times x squared by 4x. So I'll put 4x at the top and times all of this by my x squared minus 2x minus 15. Same again, take away those equations. I'm left with minus 6x squared plus 13x, and I'll take my last term down. To make minus 6x squared, I need to times x squared by minus 6. So if I multiply all of that out, take them away, I'm left with x minus 13. That's my remaining factor there. So I have x squared plus 4x minus 6 plus x minus 13 over x squared minus 2x minus 15. Then to separate this part, we can do partial fractions. So I've just factorised x squared minus 2x minus 15 to x minus 5 and x plus 3. If I rearrange this equation, multiply all of by that denominator, and then we'll let x be some different numbers. So first of all, let x be minus 3. And we get minus 16 equals minus 8b, so b must be 2. On the other side, if I let x equal 5, I get minus 8 equals 8a, and a must be minus 1. So I'll just write out all of that function all together with my partial fractions included too. We have x squared plus 4x minus 6 plus 2 over x plus 3 minus 1 over x minus 5. Now, question 6 is one of the more difficult ones to understand, but we'll read this really carefully. So arc BAD has centre C. So we can do the area of that sector because we know the centre of that circle will be at C. We just need to find that angle, the angle of the sector, and we can do that using basic trig. So that angle is 2 pi over 3. I'll keep this all in radians because my final answer is in terms of pi. So the area of my sector is the angle divided by 2 pi times by pi r squared, where my radius here is 4. So that was my angle over 2 pi being a full circle, times by pi r squared, area of a circle. So from that simplifies just to 16 pi over 3. So we've got that full area of that whole sector. The next part that we want to look at is the area of these triangles. So we'll look at that triangle DAB. The area of a triangle is half AB sine C, and we know that angle is 2 pi over 3. So we can easily sub those in to find the area of the two triangles at the top for root 3. So the area of the 4 triangles altogether will be 8 root 3. So if we have our area of a sector, the whole thing, and then we have our area of the 4 triangles, we'll take them away, so we're just left with these shaded parts at the top. So that was 16 pi over 3 minus 8 root 3, and because they were just the top 2 shaded parts, we just need to double it for the bottom 2 shaded parts as well. And then it works out quite nicely from there. Question 7 is parametric equations. So first one, x equals 1 plus 4t over 1 minus t. I'll rearrange this one for t first, and then I'll sub that into y to get our Cartesian equation of c. So t equals x minus 1 over x plus 4. If I sub that into y, it looks quite messy from this point, but if we do some rearranging, we'll get to our nice Cartesian equation in that form. So I'll sub in t equals x minus 1 over x plus 4. We've got a lot of fractions over fractions here, so I'll multiply a few things out. And simplify and expand everything. and I'll collect my x terms together, and I'll collect my constants together as well. And then we have our final answer. The next part is given that C is a line segment and the gradient of the line is -1. So if we know the gradient of the line is -1, because it's in the form of y equals mx plus c, 2 plus b over 5 equals -1. And we can rearrange that to solve for b. So the equation of that line equals minus x plus 3. This line, it goes between t equals 0 and t equals 1. So back to my parametric equations, when t equals 0, x is 1 and y is 2. And when t equals 1, if I sub that into my original equations, x is -3/2 and y is 9/2. So then we can find the length of this line segment. So the distance between 2 points in our distance formula, we should get square root of 50/2, which simplifies to 5√2/2. Question number 8. The first part that we need to do is differentiate our h. So we have one function divided by another, so we need to use quotient rule for this. So we'll let u equals 4t to the 2/3 and v equals t squared plus 1. So we can calculate du, which is 8/3 t to the -1/3, and dv, which is just 2t, and put it all into our formula. So we have 8/3 t to the -1/3 times t squared plus 1 minus 2t times 4t to the 2/3 all over t squared plus 1 all squared. And then we've just got a little bit of simplifying just to make it look like our answer. So I want to take out 8/3. And this is 8t to the 5/3. So we'll just need 3t squared for that part. You can expand all of this and then simplify it. But you should get to the final answer of 8 times 1 minus 2t squared all over 3t to the 1/3 times t squared plus 1 all squared. The next part, explain whether this is increasing or decreasing function when t equals 2. So if we sub t equals 2 in, we just want to know if this is a positive or negative number. This is negative, so the function is decreasing. And then we want the exact time when the soldier reaches maximum height. So it reaches its maximum height at the turning point when the derivative equals 0. So if we set all of this equal to 0, this is a really nice equation to solve. We can multiply up by the denominator, divide everything by 8, and we'll get our final answer of t equals 1/√2. Now on to our trig proofs. So first we've got tan to the 4x. I'm going to split that up into tan squared times tan squared. Our solution is in terms of sec and tan. So I'll use one of our identities to change a tan into a sec. The identity that links them comes from sine squared plus cos squared equals 1. If I divide all of that by cos squared, I get tan squared plus 1 equals sec squared. So if we rearrange that for tan, and I'll sub that in and expand it all. So tan squared times sec squared minus 1 is tan squared sec squared minus tan squared. It's looking quite similar to what I want, so I just need to change the last part of that equation, the tan squared. I'll sub in my identity one more time, and I'll have everything that I need. I'll just rearrange it so it looks exactly what I was trying to show. For part B, we need to find the exact value, so still in terms of pi, of the integral between 0 and pi over 4. Because it's a hence question, I'm going to use what I've just proved in the last part. The worst part to integrate there will be the tan squared times sec squared, so I'll look at just that part first. And then we can easily integrate the 1 and the minus sec squared at the end. This is a nice one because if I differentiate tan, I get sec squared, so we can almost use reverse chain rule here. So if I let u equal tan, then du by dx equals sec squared. If I rearrange that for dx, I get du over sec squared. And if I sub all of that in, my sec squareds will cancel out, and I just get the integral of u squared. If I sub back in what I had for u, then we finally get 1/3 tan cubed. So if I integrate my 1 and my minus sec squared as well, and then I'll put my limits in, pi over 4, and then minus everything with a limit of 0 in. Next, onto proof by contradiction. So given a rational number a and an irrational number b, we want to prove that a minus b is irrational. So using proof by contradiction, I'll keep, given that a is rational and b is irrational, and we'll try and prove, or we'll try and assume that a minus b is rational. Hopefully we won't be able to prove this, so then we'll have a contradiction. So if a is rational, we can write it as a fraction, m over n. You can use any letters here. A minus b is also rational, so I'll use p over q. So if I sub those into a minus b equals p over q, rearrange, get it over one fraction, I've got this one fraction equals b, so then b must be rational. So there is our contradiction. Since b is m times q minus p times n over n times q. So therefore, we have that a minus b must be irrational. Next is graphs. So first we just need to sketch the graph of f of x. I'll do this in stages. So first I'll plot 2x plus 3, and then I'll take the modulus of that, so reflect anything negative. We only have positive values. And then I'll do minus 4, so we'll take all of that graph down by 4. You can calculate each of the points of intersection with the axes then, if you just sub in x equals 0 and then y equals 0. So you should get minus 7 over 2 and 1/2. A nice 5-mark question. Next is to find the coordinates of the points of intersection with this graph and minus 1/4 x plus 2. Another nice 5-mark question. So first of all, I will solve 2x plus 3 minus 4 equals minus 1/4 x plus 2. This is a nice algebra one just to rearrange for x. And we should get x equals 4 over 3. We can sub that into either equation then to find our value for y, and we'll get the corresponding value of y is 5 over 3. For the next part, I want to solve minus 2x plus 3 minus 4 is equal to minus a quarter x plus 2. And then I'll do the exact same thing, find my x value, sub that back in to find my corresponding y value. And I'll have those two coordinates of where the points of intersection of those graphs. Next is another trig proof. We've got sine 3 theta plus cos 3 theta all squared. So if I multiply that by itself, I have sine squared 3 theta plus 2 sine 3 theta cos 3 theta plus cos squared 3 theta. We know that sine squared plus cos squared equals 1. So that holds for sine squared of 3 theta plus sine squared of plus cos squared of 3 theta. We also have a nice identity for sine of 2x, which is 2 sine x cos x. So if I sub that in, I get 1 plus 6 theta. 3 marks for 3 lines. The next part is to solve this equation. I've just took the square root away there. I've squared both sides. And if I rearrange this for sine of 6 theta, it works out quite nicely to root 2 over 2. I want to change my limit of theta. Theta is between 0 and pi over 2. I'm working with 6 theta. So 6 theta, if I multiply both of them by 6 theta is between 0 and 3 pi. So my first solution there is pi over 4 for 6 theta. If we draw our sine graph, we'll be able to see our other solutions too. So we have our first solution, pi over 4. Our next solution will be at pi minus pi over 4, which is 3 pi over 4. We need to do a few more solutions here, so everything else will be plus 2 pi from the solutions that I've already got. So pi over 4 plus 2 pi is 9 pi over 4, and 3 pi over 4 plus 2 pi is 11 pi over 4. If I divide each of those by 6, I'll get my values of theta, and these will be in the right interval between 0 and pi over 2. I can simplify those a little bit, so I'll get pi over 24, pi over 8, 3 pi over 8, and 11 pi over 24. Next we have a binomial expansion, but we actually have 2 questions in one here. At least we've got to show that question so we know the answer that we're looking for. So the first term, I'll divide everything by 2, so that I've got a 1 plus 3 over 2x to the power of minus 1. I can leave the 3 outside then and sub everything into the formula in the formula sheet. I can do the same with the next term as well. So for that one, I should get 3 minus 9 over 2x plus 27 over 4x squared. My next one, if I take the denominator up to be a power of minus 1, divide everything by 3. So I've got a 1 in that bracket, and then I can use that nice formula for binomial expansion. Finally, multiply everything up by 4 over 3, and I should get a 4 over 3 plus 20x over 9 plus 100x squared over 27. So the original question was the first one minus the second one. So if I just take away both of those expansions, I get 5 over 3 minus 121x over 18 plus 329x squared over 108, which was exactly what I wanted. The next part is to find the exact value of f of 0.01. So for the exact value, I want to sub that into our original question, not my expansion that I've just calculated. So for 0.01 in as x, and then I'll write my answer to 7 decimal places. To find the error between my expansion and the exact answer, I'll sub in x as 0.01 into my expansion as well. I get a quite accurate answer, 1.5997, and then it goes off a little bit. The next thing that I want to do is just find the percentage error. So I'll write down the value that I got in my expansion, ending in 491, minus the exact value over the exact value. Times that by 100 for a percentage, 0.001. Next up is sequences. Two really easy parts here. The first one is the nth term. I can't believe you get this at A level. 5 squares in the first pattern, 8 in the next one, 11 in the next one. Nth term is 3n plus 2. For the next one, more of an A-level question. We have 948 squares used in the first k patterns. So that was my sum of k patterns. So we know a formula for the sum of n terms of an arithmetic sequence. We know that the first term here was 5 and the difference between each one was 3. We know that the total sum here is 948. So if we add all of these in, we've just got to show this quadratic. We don't even have to solve it. An easy 2 marks. So if we expand all of that, get it all onto the same side. I've multiplied it all by 2 there. And we've shown our final solution. Finally, we have y equals x sine squared, and we just want to integrate this between pi over 2 and pi. If this was differentiation, we'd want to use a product rule, product of two things, but since this is integration, we want to use integration by parts. So we'll let u equals x. One I want to differentiate, one I want to integrate. I'd like to differentiate x because I just get 1. To integrate sine squared, we know a nice identity for sine squared, and we can easily integrate cos of 2x. So dv is a half minus a half cos 2x, and then if I integrate that, v equals x over 2 minus sine 2x over 4. So if I put that into my integration by parts formula, we have one final integration to do then. I definitely recommend in this one multiplying it all out at each phase. A lot of people with this question take out a factor of a half and then take out another half, and kind of lose track of them along the way. So integrating x over 2 is x squared over 4. And then if we want to integrate sine 2x over 4, we get cos 2x over 8. And finally, I'll put my limits in. We want the exact value again, so it's definitely easier to do as much as you can, not use any calculator. Leave it all in terms of pi. And that should simplify to 3 pi squared over 16 minus 1 over 4.